This is the fifth mini-lecture for section 13.2. We're going to conclude our discussion of measuring the variation of data by looking at a measure that goes hand in hand with the mean or average. So if x1, x2, and so on up to xn are the values in a set of data, let x bar denote their mean, then s equals this thing, which you compute by taking the difference between each element and the mean, squaring it, adding them up, dividing that sum by n, and then taking the square root. That value is called the standard deviation. There's an alternate formula that in practice is easier to use with a calculator. It comes out to the same thing, but to use it, you square each of the values, you add them up, you divide that sum by n, you subtract the square of the mean, and then after all that you take the square root. Again, the order of operations is very important there. The standard deviation measures how much the data tends to differ from the mean. Expect it to be a positive number that is small compared to the range of the data. Okay, so if you get something like negative 15,000, then you know that you probably messed up the order of operations. Okay, and you really need to practice it a few times to make sure that you understand how the formula works. It's pretty cumbersome to use for large data sets. For instance, if I were to do this for R, S, and T, that would take a while. But let's do it for a smaller data set with some smaller values. So we have this data set's 10 values, and I want to find the mean and the standard deviation of this set. Okay, so the mean is what I get when I add these up, divide by the total number of scores. It'll be 7 plus 3 plus 7 plus 8 plus 5 plus 7 plus 6 plus 9 plus 6 plus 5 divided by the total number of scores, which is 10. So I'm getting 63 over 10, which is 6.3 for the mean. Now the standard deviation. So let me write out what the formula looks like, but I'll talk about how to do this in practice on your calculator. So you're going to be adding up the squares of each of these numbers. And I think it's helpful to just write those squares down somewhere before you start adding things up. Okay, I'm just going to do it here, but if you didn't have space, maybe if there's like 15 or 20 scores, you got to just write them down somewhere on a piece of paper. Don't try to do it in your calculator all at once. Okay, so 7 squared is 49, 3 squared is 9, plus 49, plus 8 squared, which is 64, plus 5 squared, which is 25, plus 49, plus 36, plus 9 squared, which is 81, plus 36, plus 25. All of that divided by the total number of scores, minus the square of the mean. I'll just write it like that for now. And then after I do all that, I'm going to take the square root of everything. Remember, the square root comes last. Okay, so I'm going to add up those squares. Can I get 423 divided by 10 minus 6.3 squared? So this is 42.3 minus 6.3 squared, which is 39.69. And try to round as little as possible when you do this. Okay, when you square the mean, try to write at least a few decimal places. Okay, the square of the mean in this case happens to be exactly what I've written down. But if it's not exact, make it as exact as you can. Write a few decimal places. Okay, so I perform that difference, and I get the square root of 2.61. Which is about 1.6. We'll write 1.62. Okay, so the mean was 6.3. Standard deviation about 1.62. Okay, and you know, that's around what we'd expect. We have a range of, will be 9 minus 3, which is 6. So the range is 6 here. And this is small compared to that range. So remember, for the standard deviation, you're expecting a positive number that is small compared to the range of the data, which is the difference of the upper and lower score. Okay, so this number 1.62 provides a measure of how much the data tends to differ from the mean, 6.3. Okay, let's make that a little bit more exact. Okay, in the previous example, let's compute what percent of the data is within 1 standard deviation of the mean, within 2 standard deviations, and within 3 standard deviations. Okay, so what we want to compute, well, we have the mean, and we want to compute the mean plus standard deviation, the mean plus 2 times the standard deviation, the mean plus 3 times the standard deviation. The same thing in the other direction. Okay, so I just start in the middle. We have 6.3. And then I add 1.6. We'll just use 1.6. That's good enough for what we're doing. 7.9. Add it again, and we get 9.5. Add it again, and we get 11.1. The other direction, 6.3 minus 1.6 is 4.7. Subtract again, get 3.1. Subtract again, we get 1.5. Okay, so let's make a little dot plot. I'll make it go from 1 to 12 so that we include everything here. And let's see our data. We have a 7, a 3, another 7, an 8, a 5, another 7, a 6, a 9, a a 6, and a 5. Okay, so that's what the data set looks like. Okay, the mean is 6.3. We'll put a little error there. Okay, the mean plus the standard deviation at 7.9. Mean minus the standard deviation is 4.7. So I look between those two values. So there's 1, 2, 3, 4, 5, 6, 7 of our scores in there. So the answer to this first part so within one standard deviation, it's 7 out of 10, or 70%. Okay, within 2 standard deviations, let's see, we're going from 3.1 to 9.5. And 9 out of the 10 scores are within those values. So within 2 standard deviations, it's 9 out of 10, which is 90%. And the 3 standard deviations, well, it's going from 1.5 up to 11.1. And that's all of the data within those 2 values. So within 3 standard deviations, it's 10 out of 10, which is 100% of the data. And this is what you typically expect. Within 1 standard deviation, you have the majority of the data, usually around 60 or 70%. Okay, within 2 standard deviations, you have more of the data, usually most, like in the 90% range. And then within 3 standard deviations, you typically expect to have all or practically all of the data. So this kind of helps you see how the idea of the standard deviation works. Again, the vast majority of the data is going to be within 1 standard deviation of the mean. Usually around 60 or 70%. It depends. It can vary from that, but that's kind of what you expect. Then within 3 standard deviations, you expect 100% or almost 100%. Okay, so it's very rare to find data that's outside of 3 standard deviations of the mean. And if you look at the dot plots for R, S, and T on page 696 in the textbook, you can see that same kind of picture there. Okay, so look at page 696 and see how they're using the standard deviation. Okay, so that concludes this section, the homework section 13.2, exercises 1 through 10.